Alright, so we're solving quadratic equations using what's called the square root method. And this method is going to be used primarily for types of problems like this that have no middle term. And another way you can think about it is they're going to be used for quadratics that only have one variable in them. If you notice in this example down here, I have the x squared, but I don't have that middle x to the first power, right? So there's only one variable in this problem, and that's going to be the case that we're going to look for in order to use the square root method. So there's a few steps here. If you like following steps, we're going to go down and look at the example, and you'll see these being used. All right, so the steps basically say that we're going to try to solve this just like a linear equation. So here's what this means if you haven't seen linear equations in a while, or you don't know what they are based on their name. If I gave you something like this, 2x plus 6 is equal to 12, and I asked you to solve this, our job would be, let's get x alone and make it say x equals, and we'd go through this whole process of removing all of the things that are on the same side as our variable, right? And we'd say, okay, well, I've now isolated my x, and I'd say in this case x is 3, right? And so when we have a situation where there's no middle term, we can use the square root method, and we're going to do the same thing. We're going to get x squared alone, and then the last step is going to be to square root away the squared, because squareds and square roots are opposites of each other, and they'll cancel each other out. So if you take a look at this example, I'm basically going to look at this and say, all right, the left side is x squared and a minus 16. My job is to get x squared alone, so I'm going to say let's add 16 to both sides. All right, and we're going to say, all right, that leaves me with x squared is equal to 16. All right, and then now that the squared is isolated, it's alone on the left side. Now I'm going to square root. So I'm going to say, now if I square root a squared, well, that squared and the square root both cancel, and I'm just left with x. And now here's the tricky part. We're going to square root 16. Okay? And the square root of 16 actually has two answers. One of the square roots of 16 is probably what you're thinking, and that is 4. Right? The other possibility is negative 4, and here's why. Okay? The definition of square root is what number, when I square it, gives me, in this case, 16. So if you take a look, 4 squared does give me 16. However, negative 4 squared also gives me 16. So whenever we're square rooting a number, like 16 or 25 or any of those numbers, we actually have to say there's two possibilities, 4 and negative 4. Another way you might see this written, instead of as two separate statements, you might also see it written as x is equal to, and there's the symbol plus or minus 4. So this little symbol with the plus sign and the minus sign stacked, that would be another way of writing plus and minus 4 both at the same time. So this line here, x is equal to 4, x is equal to negative 4, means the same thing as x is equal to 4 or negative 4. All right, so that's the basic idea of the square root method. We're just going to look at a few more examples and some kind of special cases of things that happen. All right, so in this next example here, I'm asking you to solve the quadratic equation using the square root method. So our job is to get squared alone. So I'm going to say, all right, minus 9 on both sides. And that leaves me with the x squared is now isolated. Now here's what happens with this strange example. Okay, I'm going to square root, and I'm going to square root, and now I'm left with x on the left. But if you try to take the square root of negative 9, and you can check this on your calculator, it's going to give you an error message. Here's why. The definition of square root is what number, when you square it, is going to give you negative 9. Okay, well, it's impossible to take something like 3 and multiply it by itself and get negative anything, right? Even if we tried negative 3 times negative 3, we still end up with a positive answer. So there's no way to multiply something with itself and get a negative anything. So I'm going to say, oh, can't do it in this case. This is a case where I'm going to say there is no solution. And that's going to happen anytime you get to the square root step and you're left with a negative number. You can't square root a negative because it's impossible to do this. So I'm going to say there is no solution. Okay. And this last example that I'll show you in this video just has one additional step. Again, the idea is let's isolate the x squared. So I'm going to get rid of this 200. Let's add that over. And then here's the difference. I'm left with 2x squared is equal to 200. And this is still not isolated. I have to divide away a 2. This is 2 times x squared. I'm going to divide. And it looks like x squared is equal to 100. Okay? So now that x squared is alone, I'm going to say now I can do the square root. The square root of x squared is just x. The square root of 100, remember, is not just 10. It's also negative 10. Okay? So I'll write it like this. Again, if you wrote it as plus or minus 10, that'll do the same thing. So they both mean the same thing. You don't have to write both, just one or the other. I just want you to see both for these first few examples. Okay, and so that's the square root method. The idea is solve it just like you normally would a regular equation that just has x, and then square root on the last step. And don't forget that you have a positive and a negative version when you square root.